Hi, I'm going to start with the fifth model we talked about, so so far we have talked about four queuing model, and this is the fifth one, which is the MM1 finite population model. And this model is basically assumes we have Markovian arrivals, we have exponential service times, we have one server, infinite waiting rooms, and but only finite customers, finite population that can request the service. So sometimes this model is referred to as the machine repair problem because in this model basically are finite small number of machines and there is one repair person. So when they fail, they go and wait for service, they get repaired and they come back for service. And this notation comes from the manufacturing settings. So we're going to use the formulas in the book on this. Actually, we don't want to use them, but they are there if you need them. But instead, we're going to use the Excel model. But before I continue with the cost analysis, I just want to draw some distinction between this model and the other models we did before. So I'm going to use my tablet here. And so the models we used before, we had customers arrive at a queue where you have a single server, and then after they finish service, they leave. Okay. We had other models, so that was our first model. The second model, we had multiple servers. We have two servers, maybe, and then or more, and customers arrive. And the third one we had K server but no waiting space where customers can wait. And the fourth one we had one server but the service time was not exponential, it was general service times. But in all these models, our population here was infinite. So potentially customers come in from an infinite population at rate lambda. And in this new model, it's different. So think with how we have a repair person here, okay, that repairs machine that fail. Machine that fail can wait here, but here we don't have an infinite waiting population. We only have a finite number of machines. Say I have here one machine, two, three, four, and five. And when these machines fail and each one works for an exponential amount of time with rate lambda, when these machines fail, they go in here, they wait for repair, and then once after they get repaired, they go back up and they start functioning. So you can see how this model is different. So the arrival rate here is not really lambda, it is state dependent. So the arrival rate is state dependent. And in this situation, we would need also to compute an effective arrival rate, which is given in your textbook, and the formulas are slightly different from the formulas for the above models. So that's the distinction. And then, but still, the performance measures would require computing lambda effective, L, LQ, W, WQ, and the rate at which the server is busy, which would be lambda effective over mu instead of just simply lambda over mu. Okay, so now and so in an Excel worksheet, you'll be able to do all of these calculations. In all these Excel worksheets we have also there's a cost analysis component. So when I talk about the cost pieces of the economic analysis, so when you have a QA model, any of these five models we talked about, what are the decision variables? What are the things we can change? So we can change arrival rate, we can change the service rate, we can change the number of servers, or the queue capacity in some cases, or the finite calling population. If I had 5 machines and I purchased 2 more, I would end up with 7. And there may be others. So cost components, this is the more important part. So how do we measure cost? You have to be careful that we measure cost always per unit time. And so it's going to be cost per server per unit time. So per hour or per minute or per day or per month or per week, whatever unit of time you use. And you use CS for that. Uh, so sometimes we also have the cost per idle time per server per unit time, and the cost per busy server time per unit time. Say if you have a server where you pay them when they are busy, but you don't pay them when they are idle, or they pay them a different rate when they are not working versus when they are working. But sometimes you pay, like human servers, tellers, you pay them whether they are busy serving customers or waiting for the next customer, the same rate. So that would be the same amount of time here. Uh, so this is called the service cost, the cost of providing the service. There's also the cost of waiting. So when a customer, so the cost of providing the cost of waiting. So when customers wait at a bank, they got frustrated. There's a cost. They don't come back, so there's a cost to the system, and that's called C. You're gonna go use that CW, and that's the cost per customer per unit time of waiting in the system. So the longer the customer wait, the larger this value. We can also have cost per unit time of being in service and the cost just being waiting, but most of the time we use just the cost of being in the system. So the and this is usually is estimated by it takes some effort to do the estimation. This is easy because this is what you pay server, but this is a little bit harder to compute, although it's usually it's very significant. Cost per denied entry. So if you have a system where, like the loss model we had, where customers are cleared, there's a cost for denying a customer access to the service. Uh, Also cost per unit time of adding one position of the queue capacity. So these are different types of cost, and we can see here the total cost for the system is the waiting cost. So that's the waiting cost per customer per unit of time times L, which is the mean number of customers in the system, plus the service cost times how many servers you have. And you can say all the so for these the CW and CS should have the same unit. Against cost per unit time should be the same unit of time. And one thing you notice about this is when this goes up, this goes down. When this goes up, this goes down, because we can, depends on the service level, we can control the waiting cost. So these push in different directions, and we want to balance that. We want to minimize the cost so that this quantity is minimized, and your Excel worksheets will allow you to do that by just simply entering those cost pieces into the model. Okay, so this is my third video on queuing, and thank you. Take care. Bye.